Hello and welcome to the physics lab. This week's lab is magnetic field in a slinky. First, let me introduce today's lab assistant, Karishma. Say hello, Karishma.
Hello.
Very good. She got it right twice in a row. All right. Now this is a slinky. Now, slinkies are a lot like Karishma. I don't have much use for them, but they make me smile when I push them down the stairs. Okay, so how do we do today's lab? We have our power supply. The red cable goes over here to the switch. It's very important that you have the switch. As you see, this turns it on and this turns it off. When you're not taking data, you want it to be off! And then the cable comes back over here and clips on to the slinky. Then you have the red cable here going on the slinky back to the minus on here. Okay? You got that? Good. Because I'm not going to go over it again. Now, the magnetic field sensor we're using is this thing right here. Now, you have to be careful. Come on over here. Take a look here. You see? Don't trip over anything. We're down the stairs. The little square, you gotta come over to this side, look this way. See that square? Right here? Yeah. Okay, well, you wanna make sure there's a square there and you wanna make sure it's pointed down the axis of the slinky. All right? That's very important. If you don't, you won't get good data. You'll get lousy data, and you'll deserve it. Okay. So you set it up, right now I set it up so that the center of the slinky is at 100 on the meter stick. It's a 2 meter stick. All right? And I put I moved because Bibhu ran into the ruler last time. Okay, so you put it right at, so the meter stick is at 100, and the magnetic field sensor is at 100. Then you stretch the slinky out till it's at 75 and 125. So it's 50 centimeters long, or 0.5 meters. Okay? And we have this magnetic field sensor here, which goes to logger probe. And if you look at logger probe, it's all black because the screensaver went on. And look at the magnetic field in a slinky. Now, if we start taking data now, we're going to get crap. And the reason is because the switch is off. Because my lab assistant didn't turn it on. But before she does that, there's something very important that we should do. Do you know what that would be, Karishma?
Turn the power supply off?
No.
No.
Think about the grades you usually get on the quizzes.
100?
No. But you're close. What kind of grades do you usually get?
0.
So what should you do with the magnetic field sensor?
Make sure you 0 it.
Make sure you 0 it. This takes care of the Earth's magnetic field. Me? I can't keep a straight face? Look at her. She can't even stand up straight.
Oh, God.
So make sure you 0 your magnetic field sensor. It's just like you did with the force probes. You hit the 0 button over here. And then you look and you read to make sure it says it's roughly 0. Okay, good. So now we're ready. We turn the switch on! Oh, wait, don't do that yet. Okay?
Are you serious?
You hit collect first. Yeah, don't turn it on yet.
Turn it off?
Turn it off. That would be the opposite of on. So we hit collect, and after it goes for a couple of seconds, I want you to turn it on, and you'll see the data go up like that. That's important. Okay, you ready?
Ready.
All right. I hit the collect button.
Tell me where to go.
Now would be good. And you see it jumps up like that. Now we have it right now set to 0.5 amp. Okay? That's one data point we're going to need. So you want to adjust all this beforehand. Okay? And then you hit stop, and you grab the data, and it's flat, so you use stat. All right. So now we have our data point. The mean is 0.1087 and our current is 0.5. Notice something, we don't really care what the voltage is. All we're going to do is adjust the current until we get 0.5. Now, we're done with this data point, so what should we have already done? My lab assistant is obviously not measuring up. Turn it off. The reason for this is because this slinky will get hot, especially as we go to higher currents. We do not want that to happen. It didn't that time. So now what we'll do is, now we're going to adjust it for the next data point, which is, if we look in the manual, 1 amp. So watch as I adjust it to 1 amp. Turn the switch back on, please. What you do here is you have to, it's a combination of messing with both of these. You increase the output current until it gets to 1. Perfect. Now, at this time I didn't have to adjust the voltage. Sometimes you have to adjust the voltage too. Okay, so now my lab assistant will turn it off again. And we will collect more data. And now, turn it on. Oh, look, there's more. And then we hit stop. And we grab the data. And we do stat, because it's flat. And we have a mean now of 0.2180. And we can keep filling it up for 1, that was 1 amp, then we do 1.5, and then we do 2 amps. Now Karishma has once again, forgotten how to do her job of turning the power supply off, or the switch off. All right. So anyway, then you figure out the length of the solenoid. Well, that's 0.5 meters. The number of turns, you have to do something called counting. And you count each one of these coils, all right? And then you figure out the number of turns per meter. You divide the number of turns by the length. Okay, that's part 1. Now it's time for part 2. 2. Okay? So what do we do here? We're going to change the length of the spring, but leave the current constant. Right? So if we read the thing, it says we want lengths of 0.5 meter, 1 meter, 1.5 meters, and 2 meters. Well, we already have it set up for 0.5 meter. How do we set it up for 1 meter? What do you think, Karishma?
Spread it longer.
Spread it longer. So this is really hard. So you take your end and you put it out to 150. And I will take mine and put it out to 50. See? Wasn't that easy? Even Karishma could do it. And now we're going to keep the current stable at 1.5 amps, 1.5. All right, so why don't we adjust it? Go ahead. Remember, this is part 2. So we adjust the current to 1.5 amps. And this is when the thing starts to get hot. So I don't suggest, like sticking your tongue on it. PK probably no. That's why I have to say these kinds of things. He's already looking at it and he's drooling, thinking what it would taste like. All right, so then we take our data again, switch off.
Really good.
She's really good at flipping this. Just turn the switch on. PK has to remind me. All right. So then we can stop. And this time Karishma actually remembers. And then we have our mean data. That's for 1 meter, and you'll have to figure out the turns. Now, the number of turns don't change, so all you have to do is just to make it a different division, right? Turns per meter, it's easy. Then we do 1.5 meters, and we do 2 meters, and then you know what? We're done. except by putting all our data into the data sheet that I'll provide for you, and you can fill out. Okay. You got it?
Yeah.
Oh wait, that's right. You can't talk because this is a video. I forgot. Again. All right. So then we have to do some analysis. One of the things you plot is magnetic field versus current. That sounds pretty easy. You got the data points. And you determine the equation of the best fit line. It's going to be a linear fit. All right? Then you also have to figure out the permeability of air. Permeability. Can you say permeability, Karishma?
Permeability.
I knew you could. Just like Mr. Rogers' Neighborhood. And you have to look up the value of permeability of air and compare it with your experimental value. Because what you get is you get a formula that says magnetic field is equal to mu 0 times n, which n is the number of turns, times I. Well, that mu 0 n is just going to be the slope. All right. So I know you're going to be really excited to get here, and I can't wait to see you. And I will see you in the physics lab.
Code.
Oh, I need the secret code. The secret code for this week is boom shakalaka.